Hello. So I'm John. I'm the team lead for the AutoNav senior design team. And we're a team that consists of about 8 engineering students, consisting of mechanical, electrical, and computer engineering. So we're basically designing a fully autonomous vehicle that can traverse an outdoor obstacle course. And that course consists of bounding lines that the vehicle needs to stay between, while also avoiding cones, potholes. And at one point, we have to use a GPS waypoint to navigate when the lines disappear. So we are sponsored, we're under CRO, which is sort of the Virginia Tech's competitive robotic organization. And there's about 4 other robotics teams that fall under that, and we get sponsorship from them. We're also sponsored by Torque Robotics, which we meet with them bi-weekly with SMEs to sort of help with any problems that we have. We primarily work out of the AMP lab, and we have Dr. Nowinski as our faculty advisor.
All right, I'm Dr. Nowinski. I'm the faculty advisor for AutoNav, and we're here in the AMP lab, which is so graciously provided to us by the Electrical and Computer Engineering Department. And I think overall, this team is a great opportunity for students across the College of Engineering to collaborate with each other. And I think it's an authentic kind of experience for what it's like in industry, where you're working in multidisciplinary teams.
Hi, I'm Tommy Savory. I'm part of the mechanical team. So this is the CAD model. We've worked hard on it this whole past semester. Each and every one of us, so we have 3 people in the mechanical team. We've all designed one thing, or like one component, I guess. So I did the frame. Yanni, who you'll hear from next, did the powertrain subassembly, which is what drives our robot. And then another team member, Tom, who isn't here right now, did the caster wheel subassembly. So that's our suspension system that we have caster wheels part of.
All right, I'm Yanni. I'm in mechanical engineering too. And going from the CAD model, you can now see the physical construction that we're currently working on. Right now it's unfinished, but I'll talk a little bit about where we are. So first thing you'll notice that we have these big wheels on there, and you can probably see them in the CAD. These are our powertrain subassembly. And this has been designed in CAD using SolidWorks as our software of choice. And then we've used many different types of like machining methods, such as CNC. We used a bandsaw. This plate on the bottom was water jetted out along with these brackets that hold our frame together. And also a little bit of welding that you can see on these brackets here. So it's a great experience learning about all the different types of manufacturing methods, budgeting, how you orchestrate like getting in the lab time. Overall it's been really good.
I'm Joe. I'm the software lead. And this semester has been a lot of integration and setup. We work with a Jetson, NVIDIA Jetson, and it runs Linux. So we're working in Linux and we're working in ROS, and we get to do a lot of stuff with different sensors. So we have a Z camera and a SICK LiDAR, and we get to do a bunch of cool stuff with visualization and setup. So this is the point cloud visualization. So the LiDAR sends out scans and reflects light back and then transforms it into a point cloud in 3-dimensional space. So you're seeing X, Y, Z. And there you can see me waving. And then we'll use this data, process it, use some machine learning and transformations and other tools to map where our robot is and see where we're going.
How's it going? I'm Wyatt. I'm an electrical engineer, and I'm the electrical lead for our team. So this semester, mostly we've worked on designing the circuit diagram and improving the safety features of the robot. So you can see here, there's a schematic for the robot. Our main power source is a 24-volt battery, which you can actually see right behind here is set up. So one of the systems I'm currently integrating right now is a safety light system. So I was testing the current draw of our safety light. So I plugged it into a multimeter, and you can see it's on right now. So it works fine. And we're also working on a lot of product integration. So one of the products we are integrating with the safety light is a flashing system, which is just a requirement by our competition. So we're using an Arduino to control this system. And this is just kind of how it's set up right now. We haven't connected it to Jetson, but these wires will plug into the Jetson, and we'll be able to make this flash, which will be really cool. So Yeah, I say if you like to tinker and mess around with your hands and, actually get in the nitty gritty of things and not just do design, this is a really fun project for you.